Hello guys, in this video we will talk about engineering economics and example problems per chapter. But before anything else, we will define what is engineering economics. Engineering economics is the application of economic techniques to the evaluation of design and engineering alternatives. The role of engineering economics is to assess the appropriateness of a given project, estimate its values, and justify it from an engineering standpoint. So now let's get started.
For the first sample problem, we will talk about the simple interest. Simple interest. You have agreed to loan a friend $5,000 for 5 years at a simple interest rate of 8% per year. A. How much interest will you receive from the loan? And B. How much will your friend pay you at the end of 5 years? The solution for this one is to use the formula I is equals to P and I. The interest is said to be simple interest if the interest to be paid is directly proportional to the length of time the amount or principal is borrowed. The principal is the amount of money borrowed or invested. When simple interest is applicable, the total interest I, earned or paid, may be computed using the said formula, where P is the principal amount lent or borrowed, N is the number of interest periods or years, and I is the interest rate per interest period. So in this problem, our P is $5,000, our N is 5 years, and our interest is 8%, so that will become 0.08. The answer is $2,000, and the interest earned at the end of the first year is $4,000, but this money is not paid to the lender until the end of the fifth year. As a result, the borrower has the use of the $4,000 for 5 years without paying any interest on it, and it will pay total interest of $2,000. For letter B, at the end of n years, the amount of money due, or F, would equal the amount of the loan plus P, the total interest earned. That is, the amount of money due at the end of the loan would be F is equals to P plus I. So our P is $5,000 and our I is $2,000. We will just add the two values and that will sum up to $7,000. That is our F. For the next problem, an investment earns 3% compounded monthly. Find the value of an initial investment of $5,000 after 6 years. So this topic will focus on compound interest. Whenever the interest charged for any interest period, a year for example, is based on the remaining principal amount, plus any accumulated interest charges up to the beginning of that period, the interest is said to be compound. Compound interest calculations apply to investments where the amount of interest is calculated on the present balance of the account. So the solution for our problem is the compound interest formula for compounded interest is A is equals to P quantity 1 plus R over N to the power of NP, where A is the future value, P is the principal or the initial value, R is the interest rate, N is the number of times compounded in 1T, and P is the time. Determine what values are given and what values do we have to find first. So in this problem, it is stated that it earns 3% compounded monthly. Therefore, our rate is 0.03. The number of times compounded each year is N. It equals to 12 months, and the initial investment is $5,000. The initial amount is the principal is 5,000, and the time is 6 years. The first thing we need to do is to find A. The procedure is simple as we are going to substitute the values in the said formula. So it will become 5,021 plus 0.03 over 12 to the power of 12 times 6. It will then equal to 5,984.74. So therefore, the value after 6 years will be 5,984.74. For the next problem, we will talk about ordinary annuity. An annuity is a series of equal dollar payments that are made at the end of equidistant points in time such as monthly, quarterly, or annually over a finite period of time. If payments are made at the end of each period, the annuity is referred to as ordinary annuity. For the sample problem, we have suppose a 40-year-old person deposits $4,000 per year in an individual retirement account until age 65. Find the total in the account with the following assumptions of interest rates. Assume quarterly compounding with payments of $1,000 made at the end of each quarter period. Find the total amount of interest earned. The solution. Ordinary annuities are annuities with deposits made at the end of payment period. So the future value or ordinary annuity is S is equal to R quantity 1 plus I to the power of N minus 1 over I, where S is the future value, R is the payment at the end of each period, I is the interest rate per period, and N is the number of period. So the given, as stated in the problem, R is 1,000, I is 0.06 over 4, which equals to 0.015, N is 4 times 25 as it is quarterly, so it's 4, it equals to 100, and we will just substitute that to our formula. S is equal to 1,000 quantity 1 plus 0.015 to the power of 100 minus 1 over 0.015. It equals to $228,803.04. It is the amount after 25 years. So the deposits or the contributions made is $1,000 times 100. It will equal to $100,000. And the interest is equals to FV, or the final value minus deposits. So our final value is the $228,803.04 will minus it to $100,000, and it will then equal to $128,803.04. So therefore, the amount after 25 years is $228,803.04, and the interest is $128,803.04. So for our next problem, a father opened a savings account for his daughter on the day she was born, depositing $1,000. Each year on her birthday, he deposits another $1,000, making the last deposit on her 21st birthday. If the account pays 5.25% interest compounded annually, A, how much is the account at the end of the day on his daughter's 21st birthday, and B, how much interest has been earned. So this problem shows an example for annuity due. The solution is goes like this. Annuities due are annuities in which payments are made at the beginning of each time period, as opposed to ordinary annuities where the payments are made at the end of the periods. So the formula for this future value or annuity due, S is equals to R, quantity 1 plus I to the power of n plus 1 minus 1 over I minus R, where S is the future value, R is the payment at the end of each period, I is the interest rate per period, and N is the number of period. This is an annuity due for 21-year periods birth to up to 21st birthday, plus an additional deposit which has not yet begun to be compounded as it is the girl's birthday. So uh, the given R is equals to 1,000, I is 0.0525, and N is 21 annually. We will then substitute those values in the formula, and it will then equal to $39,664.40. For the letter B, a total of 22 deposits, 21 compounded, and the last one on her 21st birthday, which is $22,000. Interest earned is the difference of the future value and the total deposits. So the interest earned is equals to $39,664.40 minus $22,000. It will then equal to $17,664.40. For the next problem, it's all about perpetuity. Perpetuity is an annuity that provides payments indefinitely. Since this type of annuity is unending, its sum or future value cannot be calculated. What happens in a perpetuity is that once the initial fund has been established, the payments will flow from the fund indefinitely, which implies that these payments are nothing more than annual interest payments. With perpetuities, it is necessary to find a present value based on a series of payments that go on forever. So our sample problem, Alan wants to retire and receive $3,000 a month. He wants to pass this monthly payment to future generations after his death. He can earn an interest of 8% compounded annually. So how much will he need to set aside to achieve his perpetuity goal? The solution goes like this. The formula for calculating the present value of a perpetuity is A equals to R over I, where R is the interest payment each period, I is the interest rate per payment period, and from the given of our problem, R is $3,000 and I is 0.08 over 12, which equals to 0.00667. We will then substitute these values in the formula. It will go like $3,000 over 0.00667, and it will equal to $449,775. Therefore, if we wanted the payments to start today, we must increase the size of the funds to handle the first payment. This is achieved by depositing $452,775, which provides the immediate payment of $3,000 and leaves $449,775 in the fund to provide the future 3,000 payments.
Nominal and effective interest rates. Now we are given with a problem that states certain operating savings are expected to be zero at the end of the first 6 months. Period 1 with 6 months. To be $1,000 at the end of the second 6 months and to increase by $1,000 at the end of each 6 month period thereafter for a total of 4 years. It is desired to find the equivalent uniform amount A at the end of each of the 8 6 month periods if the nominal interest rate is 20% compounded semi-annually. Now, we are required to find the equivalent uniform amount. To solve, step 1, we have to create a cash flow diagram that represents the problem. So as you can see, here is the cash flow diagram. Now, since there is an increase at the end of every 6 months, then G will be equal to $1,000. Now in the diagram shown, there's the symbol going to the left and going to the right. Now in between the cash flow diagrams, it indicates that the left-hand cash flow diagram is equivalent to the right-hand cash flow diagram when the correct value of A has been determined. In this problem, the interest rate per 6 month period is 10% and the cash flows occur every 6 months. Step 2. Since we are asked to solve for A, we have to let G be equal to $1,000, N equal to 8 semi-annuals, and to find for M, we have to multiply the 8 semi-annuals by 1 cash flow per year, which will then be equal to 8 cash flow per year. To solve for the interest rate, we have to divide the 20% per semi-annual over the 2 semi-annual per year, and then that will become 10% per semi-annual. To solve for the equivalent uniform amount A, we have to multiply G by the quantity of 1 over I minus N over 1 plus I raised to the power of N minus 1, which then be equal to $1,000 multiplied by 1 over 0.10, which is the 10%, minus 8 over 1 plus 10%, 0.10, raised to the power of 8 minus 1, and the answer would be $3,004.50. Therefore, at the end of the 6 months with nominal interest rate of 20%, the uniform equivalent amount would be $3,004.50. Okay, now for the minimum attractive rate of return, a retrofitted space heating system is being considered for a small office building. The system can be purchased and installed for $110,000, and it will save an estimated 300,000 kilowatt hours of electric power each year over a 6-year period. Kilowatt hour of electricity costs 10 cents, and the company uses an MARR of 15% per year in its economic evaluations of refurbished systems. Now, the market value of the system will be $8,000 and at the end of the 6 years. And additional annual operating and maintenance expenses are negligible. Use the present worth method, the PW, to determine whether the system should be installed. Whether this system should be installed. To solve this problem, we have to solve first for the value of associated cash flow and let $110,000 be the cost of the system, purchasing and installation at period 0. Now, to find the present worth of the proposed heating system, we need to find the present equivalent of all associated cash flows, and the estimated annual savings in electrical power is, given the annuity of equal to $30,000 per year over 6 period. Hence, we have an N here that is equal to 6. Now, note that the estimated annual savings means the peak demand or the energy savings that occur in a given year. This includes the resource savings from the new program activity and the resource savings persisting from the previous years. Now, to calculate the estimated annual savings, here, estimated annual savings is equal to 300,000 kilowatt hours multiplied by the 10 cents over kilowatt hours, and that will be equal to $30,000. Now, using uniform series present worth, we have to find P. We have a given A using the formula P over A and 15% and 6. So, from the formula here, as you can see, we have P equal to A multiplied by the quantity of 1 plus I raised to the power of N minus 1 over I multiplied by 1 plus I raised to the power of capital N, and that will be, and the values will be substituted to this formula, and that will become 30,000 multiplied by 1 plus 0.15 raised to the power of 6 minus 1 divided by 0.15 multiplied by 1 plus 0.15 raised to the power of 6. And P will then become $113,534.48. Given the market value over the salvage value, that will be equal to $8,000. That will be the cash flow. Now, we will use a single payment present worth. We have to find P. We are given with an F, 15% and 6. Using the formula P over F, we will have this formula P equals to F multiplied by 1 minus I raised to the power of negative N. Then, substituting the values to the formula, we will get $8,000 multiplied by 1 plus 0.15 raised to the power of negative 6. The answer of P will then become $3,458.62. Step 2. We will apply the formula present worth equals to present worth of cash inflows minus present worth of cash outflows. Then, substituting the values, we will get a PW equal to negative $110,000 plus $113,534.48 plus $3,458.62. Then we will have an answer from the present worth as $6,993.10. Now, from the calculated value, we have a present worth of 15%, which is greater than 0. We can conclude that the retrofitted space heating system should be installed. Then next would be external rate of return. Now, we're given here with a sample problem that when E is equal to 15% and MARR is equal to 20% per year, we have to determine whether the project is acceptable. Notice that in this example, the use of an E% is different from that of MARR, and it will be illustrated. This might occur if, for some reason, part or all of the funds related to a project are handled outside the firm's normal capital structure. As you can see here, we are given with a cash flow diagram. So in general, there are steps that will be used in calculating this procedure. The first is that all net cash outflows are discounted from time 0. That means the present at E% per compounding period. The second, all net cash inflows are compounded to period N at E%. The third is that ERR, which is the interest rates that establishes equivalence between two quantities, is determined. Then, the last step would be that the absolute value of the present equivalent worth of the net cash outflows at E% from the first step will be used. Okay, now here, as I said, all net cash outflows are discounted from time zero, which practically means the present at E% per compounding period. So cash flow at period zero is equal to $10,000. That's already at period zero. That's the cash outflow, yeah? Cash outflow at period one is 5,000. From the formula, P equals to F times quantity 1 plus I raised to the power of n. Substituting the values, we will get an F, which is 5,000, multiplied by 1 plus 0.15 raised to the power of negative 1. That will then become $4,347.83. That will be now our P. For the step 2, as I said, we have all net cash inflows that will be compounded to period N. Period N is the last period at E%. Therefore, the annual cash flow from period 2 to 6 is also equal to $5,000. That's the cash inflow. Now from the formula, F equal to A multiplied by the quantity 1 plus I raised to the power of n minus 1 over I. Substituting the formula, we have an A, which is equal to $5,000, multiplied by 1 plus 0.15 raised to the power of 5 minus 1 over 0.15. Then we will get an F, which is equal to $33,711.91. Step 3. As I said, the external rate of return is the interest rate that establishes between the two quantities. And this will be determined from the formula P equal to F multiplied by 1 over 1 plus I raised to the power of n, and F equals to P multiplied by 1 plus I raised to the power of n. Which means to say we have an R, okay, here, that is the excess receipts over expenses in period, and EK, which is the excess expenditures over receipts in period K, and will be the project life or the number of periods for the study, and then E is the external reinvestment rate per period. Okay, now from this formula, we just have to substitute each of the values that we have that is given and we have calculated. So we will get $10,000 plus $4,347.83 multiplied by 1 plus I raised to the power of 6 equal to $33,711.91. Then shift solve, we will get an I equal to 15.30%. Alright, now you have to remember that a project is acceptable when I% of the ERR method is greater than or equal to the firm's MARR. The MARR given was 20%. Alright, now here, from the calculated value, 15.30%, that's our I. This means that it is less than our MARR, which is 20%. Therefore, this project would be unacceptable according to the ERR method. Okay, payback period. We are given here with a sample problem that states a public school is being renovated for $13.5 million. The building has geothermal heating and cooling and high efficiency windows and a solar array that permits the school to sell electricity back to the local electric utility. The annual value of these benefits is estimated to be $2.7 million. In addition, the residual value for the school at the end of its 40-year life is negligible. Now, what is the simple payback period and internal rate of return for the renovated school? Okay, now to solve this problem, using the formula simple payback period, which is equal to initial investments over annual cash inflows. And now substituting the values given, we have a simple payback period at $13.5 million over $2.7 million. That will be equal to 5 years. So 5 years is then a good publicly sponsored project. Now for internal rate of return, which is equal to 0, which is also equal to the present worth of cash inflows minus present worth of cash outflows. So substituting the values again, present worth equal to 0 equal to $2.7 million multiplied by 1 plus I raised to the power of n minus 1 over I plus 1 plus I raised to the power of n minus $13.5 million. Shift solve, we will get 19.99% of I, which is approximately 20%. Therefore, the IRR indicates that this project is profitable for an MARR of 20% per year or less. Benefit cost ratio method. The given problem is that there's a town of Podong considering building a new downtown parking lot. The land will cost $25,000, and the construction cost of the lot is estimated to be at $150,000. Each year costs associated with the lot are estimated to be at $17,500, and the income from the lot is estimated to be at $18,000 for the first year and an increase by $3,500 each year for the 12-year expected life of the lot. Determine the B over C, or the benefit over cost ratio, if Podunk uses a cost of money of 4%. Now, to solve this problem, we have to use the formula P equal to A multiplied by the quantity 1 plus I raised to the power of n minus 1 over I multiplied by 1 plus I raised to the power of n, which was already used also in the previous sample problems, and another formula of P equal to G multiplied by 1 plus I raised to the power of n minus I times n minus 1 divided by I raised to the power of 2 multiplied by I plus 1 plus I raised to the power of n. For the present worth benefits, that means to say the income. So from the given, there is an estimated $18,000 income for the first year, and from there will be an increase of $3,500 each year for the 12-year period at 4% too. Substituting the values, we will get 18,000 multiplied by 1 plus 0.04 raised to the power of 12 minus 1 divided by 0.04, that's the 4%, right? Multiplied by 1 plus 0.04 raised to the power of 12 plus $3,500 multiplied by 1 plus 0.04 raised to the power of 12 minus 0.04 times 12 minus 1 over 0.04 squared multiplied by 1 plus 0.04 raised to the power of 12. We'll get $334,298.38. Again, that's $334,298.38. That's for the present worth benefits. To solve for the present worth cost from the given, the land will cost $25,000. The construction cost of the lot is $150,000. That will be equal to $175,000 plus the $17,500 for the yearly cost of the lot. Okay, so from the given, we also have 4% for 12 year, right? So to calculate by substituting all of these given values, we will get PW cost at $339,238.79. And lastly, to compute for the benefit cost ratio, we will have $334,298.38 divided by the cost, which is at $339,238.79, and we will get a 0.99, which is also approximated to 1. Therefore, the benefit cost ratio of Podunk using 4% cost of money is at 0.99 or approximately 1.
So let's talk about deferred annuity. So for the problem 1, a lathe for a machine shop costs 70,000 pesos if paid in cash. On the installment plan, the purchaser should pay 25,000 pesos down payment and 10 quarterly installments, the first due at the end of the first year after purchase. If money is worth 10,000 compounded quarterly, determine the quarterly installment. So the required for this problem is a quarterly installment. And for the solution, we will show you a cash flow diagram. And in the cash flow diagram, since there is a series of equal payments occurring at equal periods of time, this is an example of annuity. And the first payment of the equal payments is not occurring at the first period, therefore this is a deferred annuity. So there are formulas in deferred annuity. First is the P is equal to A times 1 minus 1 plus R over M to the power of negative n prime over R over M times 1 plus R over M to the power of M prime. And the second one is the F is equal to P times 1 plus R over M to the power of N, where M prime is the number of postponed period and N prime is the number of payments. Both M prime and N prime should be counted by compounded periods. So the M prime here in this problem is equal to 3 and the N prime is equal to 10. Since all variables are determined, we can directly substitute the values in the formula. However, since there is a down payment, we can subtract this from the original cost. Therefore, from the given, the value for P is equal to 70,000 pesos, and for the down payment is equal to 25,000 pesos. For the R, it is equal to 0.10, and the M is equal to 4, which is the compounded quarterly, and the M prime is equal to 3, and N prime is equal to 10. So by substituting and calculating, we will get a quarterly installment 5,536.99 pesos. So now let's proceed to the problem 2 of deferred annuity. So an engineer desires to establish a fund for which he will deposit a fixed amount every half a year for 5 years. Half a year after the fifth year, he will then start to withdraw 20,000 pesos every half a year for another 5 years. If the fund established will be at an interest rate of 4% compounded semi-annually, how much should the fixed deposit be? The required is the amount of the fixed deposit. And the solution, as usual, we will show you a cash flow diagram. And in the cash flow diagram, there are two transactions, the periodic fixed deposit and the periodic withdrawal. Both are annuity, however, the deposits are ordinary annuity while the withdrawals are deferred. So to solve this problem, we need to equate both scenarios at the same period of time. For in this solution, we will use the year 0 as a reference, and in this point, the present equivalent of all the withdrawals is equal to the present equivalent of all the deposits, or P deposit is equal to P withdrawal. Since P deposit is an ordinary annuity, we will use the formula P is equal to A times 1 plus R over M to the power of M times T minus 1 over R over M times 1 plus R over M to the power of M times T. And since P withdrawal is a different annuity, we will use the formula P is equal to A times 1 minus 1 plus R over M to the power of N prime over R over M times 1 plus R over M to the power of M prime. And for solving the P withdrawal, we will focus on the withdrawals and set aside the deposits. And from the diagram, the A withdrawal is equal to 28,000 pesos, the R is equal to 0.04, the M is equal to 2, which is the compounded semi-annually, the M prime is equal to 10, and the N prime is equal to 10. By substituting the values to the formula, P withdrawal is equal to 20,000 times 1 minus 1 plus 0.04 over 2 times to the power of negative 10 over 0.04 over 2 times 1 plus 0.04 over 2 times to the power of 10. The P withdrawal is equal to 147,376.9668 pesos. So for solving the P deposit from the given, the R is equal to 0.04, the M is equal to 2, which is a compounded semi-annually, the T is equal to 5 years. So after substituting the given values to the formula of P deposit, we will get the result of P deposit is equal to 8 times 8.9826. And since P deposit is equal to P withdrawal, shift solved, we will get a fixed deposit of 16,406.94 pesos. So after the deferred annuity, we will proceed to depreciation. So for the problem 1, an underwater camera is purchased for 50,000 pesos and it has an expected life of 10 years, at the end of which the estimated salvage value is 7,500 pesos. Using the straight line depreciation, find the book value of the camera at the end of 7 years. So the required for this problem is the book value of the camera at the end of 7 years. And the solution, there are several methods in solving depreciation problems, but the problem will always indicate what method to use. So in this problem, straight line method will be used. The formulas for straight line method are small letter d is equal to fc minus sv over l, d sub n is equal to n times small letter d, b times v sub n is equal to fc minus d sub n, where the small letter d is the annual depreciation, fc is the first cost, sv is the salvage value, l is the economic life, d sub n is the total depreciation until the nth year, b times v sub n is the book value of the nth year, and the n or the sub n is the nth year. So from the given, the FC is equal to 50,000 pesos, the SV is equal to 7,500 pesos, the L is equal to 10 years, and the Nth is the seventh year. So by substituting the values in the formulas, the annual depreciation is equal to 50,000 pesos minus 7,500 over 10 years. And the total annual depreciation is equal to 4,250 pesos per year. So after, we will solve that pesos. So the book value after 7 years will be 20,250 pesos. So therefore, the book value of the camera at the end of 7 years is 20,250 pesos. So now let's go to the problem 2 of depreciation. A plant erected to manufacture shoes has a first cost of 15,005% at the end of 12 years. So the required for this problem is the appraised value of the plant at the end of 12 years. So for the solution, the appraised value is equal to the book value. So there are formulas for the sinking fund method. First is that D is equal to FC minus SC times I, which is the interest rate, over 1 plus I to the power of L, or the economic life, minus 1. The second formula is that d sub n is equal to d times 1 plus I to the power of n minus 1 over I. And the last formula is the bv sub n is equal to fc minus d sub n. So from the given, the first cost is 15 million pesos. The salvage value is equal to 200,000 pesos. The L, or the economic life, is 24 years. And the N is 12th year. Lastly, the interest rate is 0.05. So by substituting to the formulas, first we will solve the annual depreciation and we will get a result of 332,569.33 pesos per year. So let's just multiply this annual depreciation when solving the total depreciation until the 12th year. So 332,569.33 times 1 plus 0.05 to the power of 12 minus 1 over 0.05 is equal to 5,293,548.121 pesos. And for solving the book value after 12 years, we will use its formula and substitute the values, and we will get the appraised value of the plant at the end of 12 years, 9,706,451.88 pesos. So therefore, the appraised value of the plant at the end of 12 years is 9,706,451.88 pesos. So we're down to the last topic of engineering economics, which is the uniform or arithmetic gradient of cash flows. So for the problem one, neighboring parishes in Louisiana have agreed to pool road tax resources already designated for bridge refurbishment. At a recent meeting, the engineers estimated that a total of $500,000 will be deposited at the end of next year into an account for the repair of old and safety questionable bridges throughout the area. Further, they estimate that the deposits will increase by $100,000 per year for only 9 years thereafter, then cease. Determine the equivalent total present worth if public funds earn at a rate of 5% per year. So the required for this problem is equivalent total present worth. So by showing to you the cash flow diagram, the deposit is increasing by a constant amount of each period, and this is an example of arithmetic gradient series. The amount of increase or decrease is the gradient. In arithmetic gradient series, the total present worth P sub t that includes the base amount A and a conventional arithmetic gradient must consider the present worth of both the uniform series defined by A and arithmetic gradient series. The addition of the two results in P sub t, or in formula P sub t is equal to P sub A plus minus P sub G, where P sub A is the present worth of the uniform series only and P sub G is the present worth of the gradient series only, and the positive or negative sign is used for an increasing or decreasing gradient respectively. So in this problem, P sub A is the present worth of the uniform $500,000 deposits, and this is an example of an ordinary annuity. While P sub G is the present worth of the gradient $100,000, and to solve for each present worth, we will use two formulas. First is that P sub A is equal to A times 1 plus I to the power of n, or the total number of payments, minus 1 over the interest rate times 1 plus the interest rate to the power of total number of payments. And the second formula is that P sub G is equal to G times 1 plus I to the power of nth year minus interest rate times nth year minus 1 over interest rate squared times 1 plus interest rate times the power of nth year, or to the power of nth year. So, where A is the uniform deposit, the G is the constant arithmetic gradient, the I is the interest rate, and the capital N is the total number of payments, the N is the nth year, and solving for P sub A from the given, the A is equal to $500,000, the I, or the interest rate, is equal to 0.05, and the total number of payments is equal to 10. By substituting these given values to the formula of P sub A, we will get a result of $3,860,867.47. And for the P sub G, from the given, G is equal to $100,000, the N is equal to 10, and the I is equal to 0.05. And note that if G is not directly stated in a problem, we will just use the formula in solving for G. G is equal to CFN minus base amount over N minus 1, where CFN, or CF sub N, is a cash flow in year N. We will just use the original formula since it is stated in the problem. P sub G is equal to 10,000 times 1 plus 0.05 to the power of 10 minus 0.05 times 10 minus 1 over 0.05 squared times 1 plus 0.05 to the power of 10. And we will get a result of $3,165,204.79. And for solving for P sub t is equal to P sub A plus P sub G. So we will just sum up the values we get from P sub A and P sub G, and we will get the result of 7,026,071.27. Therefore, the equivalent total present worth is $7,026,071.27. And that concludes the sample problems of each chapter for engineering economics. I hope you guys learned something, and I hope so. That's it. Thank you for watching.